Welcome students. In this video session, I am going to discuss about predictive parser. So predictive parser is a type of top-down parsing where we will be considering the parse tree from root node to leaf node. Now before getting into this predictive parser, we should discuss certain terms. The first thing is about non-ambiguous grammar. The grammar which we will be using for constructing the predictive parser or which we will be using for predictive parser should be a non-ambiguous grammar. Non-ambiguous grammar in the sense the grammar should not have any ambiguity in it. So that is the first point. The grammar what we have taken should be a non-ambiguous grammar. It should not have any ambiguity in it. And second thing is that the grammar should not be a left recursive grammar. If it is a left recursive grammar, then we have to rewrite the grammar to eliminate the left recursion in it. Okay. So if possible, if required, left factoring should be also applied to the grammar. So only for such a grammar we can just go with predictive parser. So let's think about a predictive parser. Now let us get into predictive parser. So for implementing the predictive parser, we will be using two functions. One is first function, another one is follow function. Only with the help of this first and follow function, we could implement the predictive parser. So what is first function? So first is a function that gives a set of terminals that begins the string derived from the production rule. So when we say first of a non-terminal, you will be getting a set of symbols, which means that when we use the non-terminal to form a string, the string's first symbol will be any one among the set. So that is what first is. Now, for example, when we have a non-terminal A, and if non-terminal A derives to C gamma, okay, C gamma. So it means that C is in first of A. So there is a meaning of it. As I said earlier, when we form a string using the non-terminal, you may get some string. So when we just analyze the string will be starting with any symbol which is in first of that non-terminal. Okay, so first of A is defined as a collection of terminal symbol which are the first letters of the string derived from alpha. Okay, derived from alpha. So hope it is clear for you. Now let us discuss with some examples. So for identifying the first of a terminal or a non-terminal, we have certain rules. The first rule is if x is a terminal symbol, then first of x will be x. So whenever we are computing first of a terminal symbol, the result will be the terminal symbol, because when we form a string using the terminal, obviously the string is going to start with the terminal. Obviously the string will be the terminal. That's why first of a terminal will be always a terminal. The next point is if we have a production like x tends to epsilon and we are finding the first of x, then first of x will also contain epsilon in it. Now this second rule, not only second rule, the rule whichever we are going to discuss is for a non-terminal, because we already discussed that first of a terminal will be the terminal. So we are discussing about the non-terminals. So when we have a production like x tends to epsilon and we are going to compute the first of x, then first of x will also contain epsilon in it. This is second rule. Then the third rule is, if x is a non-terminal and if you have a production like x tends to y1, comma y2, comma y3 till yk. If you have like this, then first of x will be first of y1 union first of y2 union first of y3 till union y first of yk. Okay, so this is the third rule. So ultimate the meaning of the third rule is that when we have multiple productions for a non-terminal, when we want to compute the first of the non-terminal, we have to find the first of all the production rules. Here x1 tends to y1, comma y2, comma y3, comma yk. Now for computing the first of x, we want to compute first of y1, first of y2, like that. We want to compute it, we have to perform the union operation. So the next rule is, suppose if we have a production like x tends to y1, y2. Now if we want to compute first of x, what we doing? We'll be computing first of y1. So first of x equal to first of y1 will be calculating, or we will be computing. Suppose when we are computing first of y1 and if first of y1 contains epsilon in it, then we have to also include first of y2 in first of x. I look at this point once again. If we have a production like x1, x tends to y1, y2, then first of x we will be calculating first of x as first of y1. So first of y1 will be the first of x. And when we calculate first of y1, you will be getting a set, right? So in that set, if you have epsilon in it, then in addition to first of y1, we have to also compute first of y2 also. So y2, first of y2 will be also part of first of x. Okay, fine. So anyhow, we'll be discussing with an example. So at that time it will be very clear. So let us discuss with some examples. So let us take this grammar. We have 5 production rules in this grammar. As I said at the beginning itself, this grammar is a non-ambiguous grammar, and also the grammar is not left recursive. We have rewritten the grammar to eliminate the left recursion in it. Okay, fine. So let us calculate the first of all the non-terminals one by one. So first, the first of E. What is the first of E? First of E will be first of T. Okay, so we have to deal with this production. So first of E will be first of T. And what will be first of T? Again, you have to look for the production in which you have T in the left hand side. So first of T, here you have the production, right? So first of T will be equal to first of F. First of F. And what will be first of F? First of F will be first of open bracket, that is one production. In this production, first of the first symbol. What is the first symbol? Open bracket. So first of open bracket. So first of open bracket is open bracket, because open bracket is a terminal. So first of a terminal is terminal. This is what our first rule says. So first of open bracket is open bracket. And you have one more rule for F, that is ID. So first of ID will be, again it will be ID, because ID is a terminal. So first of E is first of T. First of T is first of F. And first of F is nothing but first of open bracket and first of ID. First of open bracket is open bracket and first of ID is ID, because they are terminals. Hope it is clear for you. Now next, let us try to calculate first of E dash. what will be first of E dash? So first of E dash will be first of plus and first of epsilon. Okay, first of plus and first of epsilon. So what is first of plus? Obviously it will be plus because first of a terminal will be always a terminal. Then what about first of epsilon? We have a second rule, right? So what our second rule says, first of epsilon will contain epsilon. Okay, so first of epsilon is epsilon. So plus and epsilon are the results of first of E dash. Still we want to compute first of T dash. So what will be first of T dash? So first of T dash will be first of star and first of epsilon. Okay, so first of star will be star and first of epsilon will be epsilon. So this is how we have to calculate the first for the non-terminals. Hope it will be clear for you. Now before getting into the follow operation, let me just give some example for the fourth row. So far in our example, uh, we just used only the first three rules. Now just assume that we want to calculate the first of E, and for first of E we want to calculate first of T, right? Now for example, you just consider that first of E contains epsilon. In our example we haven't got epsilon. Just for example, you just consider that first of E also contains epsilon. So if first of T contains epsilon in it, then we have to also calculate first of E dash. So first of E dash will be also part of first of E. I will repeat this point once again. As per our fourth rule, when we have an expression like this, E tends to T dash, when we want to calculate first of E, we will be calculating first of T. Now just consider that first of T contains epsilon in it. So if it contains epsilon, then what you have to do is you should not place epsilon in the result. Instead of epsilon, you should include first of the next symbol. What is the first of next symbol? E dash, right? So E dash first of E dash should be included instead of epsilon. So that is what the fourth rule says. Okay. Now with this, let us get into a follow operation. So it is defined as a collection of terminal symbol that occur directly to the right of A. When we want to calculate follow of A, we have to follow certain rules. Okay. So the first rule is, if you are calculating follow for a non-terminal, and assume that the non-terminal is a starting symbol. So ultimately what I'm trying to tell is, we are calculating the follow of a starting symbol. So when you're going to calculate the follow of a starting symbol, starting non-terminal, you have to add dollar in it. Okay, you have to add dollar to it. The next rule, what it says is that if you have a production like A tends to alpha B beta, then follow of B will be first of beta. We want to calculate follow of B. So what will be follow of B? Follow of B will be first of beta. Okay, so remember this point. We have to include the first of beta except epsilon. Suppose if you have an epsilon, then you have to do something. I'll let you know shortly. So other than epsilon, we have to include all the symbols whatever you have in the first of beta. So those first of beta will be the follow of B. So the next rule is, if there is a production like A tends to alpha B, what's the difference between the second rule and the third rule? Second rule, after B you have some string, but whereas in the third rule, after B you don't have anything. So when you have a production like A tends to alpha B, then follow of B will be follow of A. Okay. Follow of B will be follow of A. Yes. So follow of B will be the follow of A. Now the next rule is a special case. So if you have a prediction like A tends to alpha B beta, we already learned that in our second rule. Already we learned that follow of B will be first of beta. Now if first of beta contains epsilon in it, then what you have to do is, other than epsilon, you have to include all the symbols whatever you are getting in first of beta, sorry. In addition to those uh, symbols, you have to also include follow of A in it. Okay, quite tricky one. So suppose when we have a projection like A tends to alpha B beta, as per our second rule, follow of B will be first of beta. Suppose if first of beta don't contains epsilon in it, then whatever we got for first of beta will be follow of B. In case if first of beta contains an epsilon symbol in it, then follow of B will be uh, first of beta except epsilon. In addition to those symbols, we have to also include follow of A in follow of B. Okay, so that is what the third rule. Now let us go with some examples. So let us take the same grammar which we used for discussing the first operation. So we have these grammars. We have grammar with these productions. Right. Now what we follow of E? Follow of E will be, what will be follow of E? So when we compute follow of a non-terminal, we have to look for the production in which we have the non-terminal in the right hand side. Now in which production you have the non-terminal in the right hand side? Follow of E in the sense, so E you have here, right? Yeah, here you have. So follow of E will be first of closed bracket. As per our second rule, follow of E will be first of closed bracket. Okay, fine. So what will be first of closed bracket? It will be closed bracket. And since E is a starting symbol, we have also added dollar along with it. As per our first rule, since E is a starting symbol, we have also added dollar. You can just compare this with the production F tends to open bracket E closed bracket. You can compare with the production A tends to alpha B beta. Here in this production, A is nothing but F, open your alpha is nothing but open bracket, and B is your E, and beta is your closed bracket. Now what is first of or how will you calculate the follow of E? So follow of E will be first of closed bracket. That's why we calculated this. That's why we got the result like this. Okay, fine. Hope it is clear. Let us proceed with the other non-terminals. So what will be the follow of E dash? So follow of E dash, when you want to compute follow of E dash, you have to look for the production in which you have E dash in the right side. So which production you have E dash in the right side? So here you have, and also here you have, right? So you have to evaluate both the ones. So follow of E dash will be follow of E. As per our third rule, when we have a production like this, A tends to alpha B, what will be follow of B? Follow of B will be follow of A. To make the point very clear, you want to compute a follow of a non-terminal, but after the non-terminal you don't have anything. If you have something, you will be computing first of it. But since after E dash you don't have anything, so follow of E dash will be follow of E. Already we calculated follow of E, right? So the same set will be the follow of E dash also. You just check whether you were getting any additional symbols by evaluating the second production also, because in two productions you have E dash in the right side. So here also you have plus T E dash. So follow of E dash will be follow of E dash. So the set remains same. So follow of E dash will be follow of E, right? So next we want to compute follow of T. So what will be follow of T? You have to look for the production in which you have T in the right side. So where you have, here you have, right? Here you have. So what will be the follow of T? Follow of T will be first of E dash. Okay, first of E dash. So already in our previous example we discussed what will be the first of E dash. What will be the first of E dash? Plus and epsilon. Okay. So we have to add that plus epsilon. Okay. So one second. Yeah, just a minute. Yes, students. So follow of T will be first of E dash. So already we computed first of E dash. So first of E dash nothing but plus and epsilon. Okay. So plus and epsilon. So you just add plus with it, and you should not add epsilon because follow of a terminal or a non-terminal will not have epsilon in it. Okay. So instead of epsilon, what you have to do, as per our third rule, suppose if first of beta contains an epsilon in it, then what you have to do, you have to also include follow of E. Okay. So since E dash, the first of E dash contain epsilon in it, we have to also include follow of E in follow of T. So follow of T is nothing but already we got plus. The first of E dash had plus, so we included plus. Now instead of epsilon, we're just including the follow of E. So follow of E already we computed closed bracket and dollar, so that we are just adding it. Right? Okay, so whenever we have epsilon in the first of the next symbol, then instead of that epsilon, you have to compute the follow of the non-terminal. Okay, the production is not the production, the left hand side of the production. Then what about the follow of T dash? So follow of T dash will be follow of, so for computing the follow of T dash, we can make use of this production. So follow of T dash will be follow of T, because after T dash you don't have anything. So follow of T dash will be follow of T. So whatever we computed follow of T, that you can, that the same set will be for T dash also. Let us also try to evaluate the one more production in which you have T dash in the right hand side. So follow of T dash will be follow of T dash. So the result remains same. So finally the follow of F. So follow of F will be, you have to look for the production in which you have F in the right hand side. So here you have, so follow of F will be first of T dash. So what will be the first of T dash? Already we computed, right? So first of T dash will be star epsilon. So what you have to do? We have to include star. Then instead of epsilon, you have to include follow of T. So what will be follow of T? Plus open bracket dollar. So that we are just including. So this is how we have to calculate the first and follow.